Okay, let's start with the prarthana. Vakratunda Mahakaya Suryakoti Samaprabha Nirvignam Kuru me deva Sarvakaryeshu Sarvada Gurur Brahma Gurur Vishnu Gurur Devo Maheshwaraha Gurur Sakshat Parabrahma Tasmai Shri Gurave Namaha Saraswati Namastubhyam Varade Kamarupini Vidyarambam Karishyami Siddhir Bhavatu me Sada. Okay, so 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 last week, we saw the two different dictionary encodings, right? The first one was essentially a simple Matrikrama dictionary where we would use pu, chu, tu, tu, pu as the one of the dictionaries. And the second type of dictionary is basically our Pratyahara. And the primary difference between these two being we are able in one case it is just a direct lookup, and the other scenario we have an algorithmic layer that is actually sitting in between, which is essentially the pratyahara that makes it extremely flexible so that you don't have to go back and touch the dictionary at all, right? So the dictionary remains as is, and we don't really have to go and essentially mess with it, but we can create new pratyahara. So basically, we have taken the software engineering approach where we have just created one level of indirection where we inserted the pratyahara layer between the Maheshwara Sutram and its uses, right? So, and we saw a good number of examples about various pratyahara. Maybe like a quick one or two example being, so at is essentially where is the yeah, in this case ach being left. So we will essentially take the first four sutras, which is ayavonalrilukku yevonga yauch, and get rid of all the letters in the end. That gives us ayevu rilu yevo ayau. And we also talked a little bit about the various variants of all these swaras, which is one is duration based, the other one is anuswara, ananuswara, so the nasal and the non-nasal component, and the third one is basically the intonations, right? One is uddhata, anudhata, and swarita. So in Vedic, there is also a dirgha swarita, but for all the Bhasha Sanskritam, we have uddhata, anudhata, and swarita, right? So that pretty much means that every swara has almost anywhere between 12 to 18 different variants, right? I'm saying 12 for certain cases, but we will not go into all those other variants and stuff, right? So, and hal, so basically, ach is all vowels, hal is all consonants or all vyanjanas, right? And so we looked at a few other stuff as well, which is jash is all the third letters in the Vargiya Vyanjanas, which is Jabagada. So, and we also briefly touched upon the exception that is provided by Panini Maharishi, where whenever you add a it to it, it allows you to cherry pick certain letters. Did we talk about the exception part last week? We did talk about tapara, right? Right. So in this case, what it does is essentially um, 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 for vriddhirechi adhengunaha, where we in this case at and ing. So whenever the it is present adjacent to any one of these, we just pick up only those variants in terms of the duration. So in this case, we will pick the nasal variants and also the intonation variants, right? So except the time durations, right? So only the Hraswa Akara, which is the short Akara, is the only thing that will be taken, and all its other nasal and intonation variants. The Dirgha Akara and its the three duration variant, which is actually called Pluta, we don't take that part into account, right? So, and what we other things saw was, so how come Maheshwara Sutram is so flexible, right? The reason is Pani Maharshi also went through some level of statistical analysis, right? And he said it came from Maheshwara himself, but he also it was given to him in a way where it is arranged in a certain notation, right? Where the initial Ayun relic is essentially single syllable vowels. There is only one syllable in there. So Aong is two syllable vowels. If you look at it, A plus E is A plus O is O. So you can see two vowels essentially work together to form A and O. And now A plus A is I and A plus O is O. That is kind of how uh, we can essentially think of, which means in this case, I and O can be considered as a three syllable vowel. And then we have Antastaha, which is Hayavarat Lan, which is essentially we make very mild moderations with our tongue to produce those. Nyamangananam is a nasal variant, all the nasal variant in one. Jabha, Ghadadha are essentially Mahapranas and Mriduvanjana, right? So you essentially pronounce them from your stomach. So that makes the Jabai Gadadash. I think it should have been Jabai. So I think I have a mistake in that slide. I need to fix that. I think some cut and paste came through. Okay. Then you have Jabagadadash, which is all the third consonants in every group. Then if you look at it, Khapa Chata Tha is all the Mahaprana of the Karkasha Vyanjana, right? The second letters in every Varga. But you also see Cha Ta Tha, which is the first letter in every Varga, also attached to it. But if you look at how the fourth letters in every Varga is added, that is actually further split into Ja, Ba and Ga, Da, Dha, right? So, but in this case, it is actually clubbed in a slightly different way. If you look at it, it is the only reasoning that we can essentially think of is on how probable these letters are towards exhibiting similar qualities, right? So a lot of thought has been gone into how these letters are actually grouped into each sutra, right? And if you look at it, ha is actually used twice, one in the beginning, Hayavarat, and one in the end, hal, which is unique in its own, because ha exhibit dual kind of a personality, right? Where you can also be used as a soft consonant, and it can also be treated like a ushmana, where it's like where you make a hissing sound, right? Sha, sha, sa, ha. They all four are ushmana, right? So, and essentially, ha has this duality in terms of how the pronunciation can be thought of as, right? And so I think I left out the kapai, which is kappa are the only two things that because you will see them in, for example, there is one sandhi called natvam where the kappa or even though it is referred to as ku and pu in the sutram, so you can see they both carry some affinity towards each other in terms of how the rules are associated with it, right? So
Even the Visarga Sandhi, right? With them, it is special.
yes. Yeah, yes. Ka and Pa. So you can actually see Ka and Pa exhibits a similar Sandhi attributes when they are used together, right? Yes. So that's kind of where we left off last week, right? So now what I'm going to talk about is, so just take a little bit step back and look at one of the early things that we talked about in terms of how the signs of pronunciation was initially set up. Let me see if I have the slide in one of the early ones, where I talked about the prayatna and yeah. So let's look at this one slide. Right. So I think we touched this one slide before, where if you look at it, so this is also we discussed in one of the earlier classes, right? Where by and large the pronunciations are divided into two parts. Okay, and one is essentially the sthana, right? And the second part is the moderation. And there are further subdivisions. We will come back and touch again after looking at the what are embeddings and how are relevant to this. But I just want to do a quick reminder about how the science of phonetics was essentially put through in the Shiksha, Paniniya Shiksha, right? So these kind of clearly define how these letters are pronounced and how we can actually understand and do those pronunciations in the right way based on where it is the sounds originate and how we are supposed to moderate them, right? And this will have implication on how we will view this in the perspective of how a concept of embeddings that is used in NLP can be applied here. Okay, so now let's go back to understanding what is embeddings. Okay, so let's kind of quickly go through this. So now we are going to kind of discuss about the whole thing in the AI realm. So we are going to switch gears from Sanskrit to the AI side of things. So let me just, I'll probably kind of use my other screen and present to you. Okay, are you able to see a blank screen as of now? Okay, I don't want to share the audio.
Black screen.
Yeah, so, okay, yeah, I think you are able to see this, okay?
Yes,
So,
yes.
so we initially talked about, let me, yeah. So we initially talked about the concept of representation of characters in these AI models. So for NLP, it is referred to, so we initially start off how different kinds of models that are present where the image is essentially kind of looked up as you basically look at small parts of the image, essentially almost looking through a magnifying glass, and you just essentially kind of go through each line and try make a sense of the individual pieces in the image and then trying to construct a bird's eye view of what is the actual image showing, right? When it comes to languages, predominantly these models are called sequence models. Okay, so we briefly touched this as well at some point. So sequence models are nothing but, so let's say you want to do a translation. Okay, so if I am introducing myself in English, you would say I am Ram, right? And this will translate to Aham Ramaha, right? So in this, it loosely translates I am is Aham and Ram is Rama, right? So that is kind of how the translations happen. So when this particular input is essentially fed into these models, it's initially broken up into small subwords. Let's call them tokens. Okay. So one simple way to basically say this is I am is the token and Ram is the token. Right. So there are two words. And essentially, let's say I take a dictionary and each dictionary word I assign a number and essentially and feed these numbers which are representative of what's the dictionary content it has, and then go through with the translation. And when it comes back, now it is going to give me some numbers that I need to refer them in the Sanskrit dictionary, right? So it would essentially say I am will loosely translate to Aham and Ram will loosely, in this case, it will come out as Ram because we use the gender represented words names in Sanskritam, but unless otherwise the model is aware of that, it will not be able to provide that information in this one, right? So we can simply say that it is going to come back as Aham Ram to start with. Okay. So initially, but if you take, let's say, a word as, let's say, okay. So take the two sentences. I walk to school. I can say, when I want to say that in the past tense, I say, I walked to school yesterday, right? In this case, I'm just saying, but without saying yesterday or last week, walked is essentially an event that happened sometime in the past, right? So if you look at it, in these two sentences, walk and walked look very similar. The only thing is adding the ed to the end gives me that information that this sentence is in past tense and this is in present tense, right? So now it might actually be better to feed these words as walk as one token and ed as another token to make better sense out of it, right? So and the door closed. So, and you can see this is actually statistically derived. So you see, you run through a large corpus or a large book of text, and you look at how often these words happen together, and you infer and essentially say, oh, you know what? Whenever there is a verb, it is usually ed is usually added to the end to make a past tense out of it. Even though there are enough English is a funny language and it has enough exceptions. Let's not get into the exception part. For predominant part of it, you can actually say you add an ed to it, and you can essentially get the past tense for it, right? And these are essentially the tokens. So some of the earlier models, the way it used to represent is, so these words would be represented using a binary scheme, a 0 and a 1. And essentially enough digits will be assigned such a way where you basically create a list where it represents this is as long as the number of words in the dictionary. So if let's say I am is essentially, let's say the dictionary has 100,000 words, then this length will be 100,000 bits. So each bit being a 0 or a 1. Okay. So in this case, let's say I is, so let's say I is, let's say in this case, 7,112th word in the dictionary. So then what will happen is whenever I feed one, so I always feed a list of 1000 bits. And each bit basically will have a one that corresponds to the word index in the dictionary. And now you can actually see if the dictionary size grows, or if you add support for way more languages, now the number of bits that is needed to actually represent them becomes extremely huge, right? And it basically bloats this number of information that the model needs to understand and tune itself to be able to do any of the tasks it is supposed to do, be it translation, or let's say in this case, it's giving you sentiments, or let's say in this case, it is trying to summarize, let's say an essay and trying to give you a gist of what is there in that in that essay. These are all different tasks that the NLP, the AI models can do today. Okay. So I'm just calling specifically going back to referring them as NLP because this we are talking about a language task. Today, these days, all of them are multimodal and multilingual models where you can feed any type of data. It can be an image, it can be an audio, it can be a video, it can be a strings. It can take any kind of input and be able to do whatever task you ask them to do. You can give a sentence and ask to generate an image based on what the sentence is. You can say, oh, the image of a sunrise with a few flock of birds flying in the sky. Then it will produce an image that corresponds to what these words describe. Okay. So, but in this case, what we are talking about is simply these models. And so we are trying to kind of confine that to this a little bit slightly older models which used to handle only text, and they used to be referred to as NLP, natural language processing, or NLP models. Okay, this is natural language processing. Okay, good. So now at this point we can see this is extremely expensive to represent a word using one specific bit for each of the words in the dictionary. You can see it is very sparsely populated and it is extremely resource intensive in terms of this representation, right? So, but if you look at, let's say if in this case, let's take well, tone down this problem down to, let's say I'm only dealing with a very simple language and this language has only 32 words. So if we consider, so let's say if you have 100 words, how many decimal digits do we need? Let's say if you start from 0, go all the way into 99, how many decimal digits you would need to represent anywhere from 0 to 100 numbers?
2.
You just need two of them, right? In this case, so that means, so basically 100 corresponds to 10 power 2, right? That is how we come to say that, oh, I need 2 digits. So in this case, we are dealing with a binary system. So 2 power 32 corresponds to 2 power 5. So that means I need 5 bits to represent 32 entities or 32 words in this case, right? So the first word will be represented as 00001. So that will be the first word. So the second word will be 00. So first word will be all zeros. The second word will be 1. Then what you'll have is, so it's like almost like how we do. We go from 0 through 9. And once we hit 9, it goes back to 0, but the next digit becomes 1, right? Which makes it 10, right? So this is also works like that. So the next thing will be 10, and the next thing will be 11, and then this will be 4. So this is 0, 1, 2. This is how we would write, right? So, but instead of doing this, let's say I try to encode these words with some semantic information. Okay. Where instead of just using 10 to 32, let's say I use let's actually go back to my slide now. So I know that I have represented this. Instead of just blindly again encoding the words as 0 through 32 for 32 words, instead I indulge a little bit and I say I want to use 3 sets of 32 bits, let's say. So this is 32 bits. So instead of these representing the words as is, these represents, let's say, attributes of the word. Let's say if you in Sanskritam, let's say you are saying you take a word, and in this case, let's say we have all the 3 vachanas, right? Ekavachanam, Bahuvachanam, Dvivachanam, right? So let's say we do say so, and I instead of just saying I one of this, let's say, actually, let's say in this case I have 3 of them. So this represents the word index in this. Let's say I represents the 5th word in the dictionary. So this becomes 5. And let's say I have 32 bits for whether it's a plural or if I, let's say this represents plurality. So this is vachanam. This is linga. This is, let's say, vibhakti. Right? Now I can even represent the words and what vibhakti I'm saying are linga, vibhakti, vachanam. All 3 I can actually mention this. So by thereby feeding the model a little bit more context on what version I am seeing. Right? Now if I, let's say I'm using Tingantam. So then I add one more and say whether I say this is Subantam or Tingantam. And then based on whether it is Subandham, I give whether what Vachanam it is, what Lingam it is, and what Vibhakti it is. So let's say if I'm using, if it is a Tingantam, I give Purusha, then again what Vachana, right? So Purusha, Vachana, and obviously there is what Dhatu it is, right? So if I can do that, then I can feed a lot of information into the model so that the model can understand better. And when it actually spits out, it can also spits out in this particular semantics where we will be able to understand and decode this even better, right? So now let's go back to my slides now, and I'll see, we'll talk about what I exactly mean with a slightly different example. Okay. So now are you able to see my back to my window again?
Yes.
Okay. Let me just go back to that. Good. So now you're seeing mine, right? So let me make sure that I can show you. Where did it go? Okay. So now, so let's take this set of, now let's say we'll simplify this problem down to extremely simple, right? So now I have taken a total of 9 words. Okay. Okay. I have taken a total of 9 words. It's man, woman, king, queen, prince, princess, a boy and a girl. If you look at it, I have taken pairs of words based on genders, just to kind of throw in a little bit of diversity in terms of these different words. I add a gender neutral word called person in the end. Okay. If you look at the representation or look at the different things that it captures, you can see there is some bit of age in there, right? Man and woman are generally adults. King and queen are also adults, right? Then prince, princess, boy and girl essentially represents, you can think of them as a little bit of youth or essentially being kids. right? Yeah, we agree with that, right? And then let's, for now, for the sake of discussion right now, we'll leave the person out for us for a moment. Okay. So then the other thing that I can see is man, woman, boy, and girl compared to king, queen, prince, princess. There is a sense of royalty in the king, queen, prince, princess, but not in man, woman, boy, and girl, right? So I can use that as one of the dimensions or an attribute of representing the meaning of this word. Okay. So then, so there is age, there is royalty. Then the first thing that we saw was there is also a gender representation in that, right? So man, king, prince, and boy, masculine genders, woman, queen, princess, and girl being feminine genders. So now I'm going to use a value from 0 to 9 and essentially assign values that carries a little bit of semantic value. Okay. Are you with me right until now? Yes. Okay. So man, woman, king, queen are adults, right? But they are not really old age or anything. This is just adults, right? So now, so I give a number close to 10, but not very close. So I give a number 7. Prince, princess is in the realm of youth. So I give number 3. Boy and girl, pretty young, 2. Okay. So they are not infants, right? They are essentially kids. That's about it, right? So instead of assigning 1 or a 0, I'm going to give a number of 2. Okay. Right. So now when it comes to the gender, man, king, prince, and boy are masculine. Let's say larger the number, it is more masculine. Smaller the number, it is more feminine. Okay. So I gave 9 to all the male gender words, 1 to all the female gender words. Now let's throw in the equivalent of the person. Person is almost an adult. So I gave a number age for the age dimension. I gave a number of 5, of a number 6. For gender, it is a neutral gender. So neither am I leaning towards a 10, nor am I leaning towards the 1. I gave a number 5. Same with royalty. So this is a royalty neutral word. So if you look at it, boy, girl, man, woman, person are all royalty neutral words. So I gave 5 in the royalty dimension. So for king, queen, prince, princess, so king and queen have a little bit higher stature in terms of royalty, right? You can always think of it like that. So when there is a king and a prince present, king takes a little bit of higher royalty compared to prince. So I assign these names, these values in there. Now, what does this allow us to do when I assign some numbers like this? You can actually see if I take if I take king minus man, and if I add woman to it. So what I've done, I've taken a word that has, so what is common between man and king? So essentially, what I'm trying to do here is, let me see if I can roll the slides forward here. Do I have the mathematics in here? Yeah, I have it in the next one. Right. So, okay. So, let's say if you look at this, king minus man plus woman. Okay. So I'm going to go back to my other share again. Okay. So remember these numbers, right? I will probably write it down too in the new screen, but nonetheless. Are you seeing my new window now? Not it? Oh, what was that? You're seeing my new screen now?
Yeah.
Okay. So now what did we do? So we have, I'll just write it down here, right? So we have a dimension of age, gender, and royalty. And the words are man, woman, king, queen, prince, princess, boy, girl, and a person. Okay. So in this case, this is a 795, 715 for woman, right? And for the king, it is 799. And queen is 719. And this is a 3, 9, and a 8. That is prince. And a 318 for princess. A boy, which is 295. And 215 for the girl. Right. And 655 for the person. Right. So now what I want to do is king minus man plus woman. So what was king? 799. And man was 795. And woman was 715. So what I'm going to do is when I do it, I'm just going to keep these dimensions as is. So if I take just these two, I'm going to not mix and match. So we will come by and see how we can do it mathematically in a more scalable way. We have actually read some of these concepts in the name of matrices, matrix calculations in our 12th grade, I guess, right? So it is almost doing something like this. So 7 minus 7 becomes 0, 9 minus 9 becomes 0 again, 9 minus 5 becomes 4. Now I'm going to add 7, 1, and a 5. So what does that give me? 7, 1, and a 9, right? Now if you go back, take this number and go look up the table now. 7 for age, and this 1 for gender, and this 9 for royalty. What does that correspond to?
Queen.
Queen. So if I can curate a representation for each words with some sensible dimensions like age, gender, or now I'm actually taking only words that represents different pronouns for people, right? But English has a whole dimensions of it, right? So in terms of like, I mean, the vocabulary is so broad. So that means I would need a lot more dimensions and a lot more wider range of values for me to be able to represent them. So if you look at it, you can do the same math again for king. So prince, so prince minus man or prince minus boy plus girl. And if you will see that this pretty much goes back to saying it is princess. Just do a mental math there, right? So you have a 398 and a 295. So if you look at it, that will give you back, sorry, uh, 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 110 and 3, and you add back the girl to it, so it will give you back 3, 1, and a 8 again, which should basically map to princess here, right? Okay. So this allows you to map all the mathematics. So if I ask a question to this model, if 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 man is to king, what would woman is to what? Now, just based on the math and doing a reverse lookup, I will be able to say this is queen, right? So the way, so and this concept of representing them using these attributes as dimensions. And obviously, if I have to represent a dictionary of words using these dimensions, then the number of dimensions would run to what? So if you look at today's Gen AI models, they use close to 3072 for the largest models, and it goes down all the way up to, I mean, if you don't want that many variants in these, like somewhere around 512, and these are also not simply integers, these are decimal values. So now look at how much flexibility I have in terms of assigning numbers, right? And this concept of representing a word, so basically what we have done, we have taken a word and mapped them to a dimension of attributes. And what the model does is essentially take this thing in. So now what it can do is it can use the semantic meaning in these different dimensions and use that to learn a lot more tighter relationship information, which is one of the reasons. So this concept came about in 2013. The only difference is 2013, so I think 2013 or 2014. So this came up with a model called word to vec, or in this case, it is called a word to a vector representation. So in this case, it is a array of 300 or a list of 3072 numbers or 512 numbers. I think the original models were 1K or something like that, 1K dimensions. And with that, and how was it actually trained? It was trained based on just making the model look at a dictionary and see how probable a specific word to appear alongside something else, right? Obviously, if you're going to tell a story about, let's say if I'm going to do a fairy tale, king and queen will be co-associated, prince, princess will be there, man, woman will be there. So now let's say if I'm trying to take a book on geography, you will probably talk about its locations, continents, capitals, countries, right? States within within the countries and things like that, right? Now, if the data is large enough and the distribution of these words cover the topic in wide range, then you would have created enough distribution for these words with what do they appear along them. Okay. So the models were so good. If when you ask, so basically, so now if you take that into account, it also poses a slight problem there. So if I ask a question, man is to doctor implies woman is to what? Take a wild guess. If man mapped to a doctor, what would a woman map to?
Nurse, huh?
Yes. So that it came as a shock and it created a lot of controversies in terms of the gender biases. So even today, if you look at it, and there were a lot of papers that came by and which identified the dimensions that carried these biases. So let's say if you had a profession, obviously, right, profession will end up becoming a dimension. There is a high chance of, so basically gender and the profession put together will carry some level of bias, because that is how the text are in the map. It's not like the model is cooking up these biases. Okay. It is just reinforcing those biases that are already present in the text. Right. And this is a huge area of research, bias and ethics. And it is still essentially an area of research. We are making improvements over and over and over again, but still 15 minutes. So another 10, so basically in this case, so it will be around, that's exactly what happened when they trained on these models. And this essentially created a lot of ruckus, and it had to be kind of fixed at some point in time. Okay.
But actually, it is more closer to the the perception we see around, right? So,
Yes.
so then, like, rather than accepting it, we are trying to tell, no, 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 we
Fix it.
don't like it,
Yes.
so you change it.
Yeah. So see, the thing is, what ends up happening is, so for example, I'll tell you where the issue is, right? So let's say, I mean, these are all very sensitive topics and has a lot of repercussion when in these papers and stuff. That's this is one of the big issues there, right? So so for example, right, in terms of these are the two biases, right? Gender, there are racial biases, right? So if, let's say if you it is say if it says a man is, so let's say uh, what is the probability? Let's say if you associated a word like, let's say, a bomber, what will be the, let's say, in this case, religious bias, right? So what is the religion that would be associated with it, right? So in case, so which is in fact we've seen in Hollywood movies, right? So yes, there are quite a bit of people in there who are extreme, who had extremist tendencies, but the issue is what is there in the text is what is being captured. And in some sense, what we are trying to do is, instead of solving those problems, it is essentially more, it's adding more fuel to the fire, so to say. Right? So it could be argued about in both ways. For example, some of the models that I kind of use this. So since it captures the bias, so some of my research work involved in cybersecurity, it so how you behave in a network is going to be based on what your biases are in terms of the resources. A developer in the network is going to access certain set of resources. Let's say a lawyer, or let's say a patent attorney in a IT company is going to access certain set of resources. A finance person is going to access certain set of resources, right? So in fact, to the point on how what kind of in one of the companies that I used to work for, I was able to figure out what type of printer, which printers in the building is bound to be used by what department of people. And I could actually figure out based on, and I'll actually get into it in a detail in the next week's lecture. Right? But we were able to say, and we actually did find a printer that was actually not there in the network, but was left lingering in terms of configuration in various finance department folks' laptops, which in itself could have been kind of leveraged as a vulnerability. Just give me one sec, guys. My wife is asking me something, so let me just quickly tell her and come back. Sorry, guys. I had to kind of just have a chat. I need to go do pick up my daughter in like another 20 minutes. I have to take the questions probably in the next class, but kind of this is so it is both strength and its weakness, right? So in terms of what application are we using, we need to be, so for example, loan approvals was bad for a black person compared to the other races, because even though the person whom in that particular example of whom we are trying to evaluate for a loan could be a well established person in the society, it would still, the model would still take into account the bias towards a black person in terms of giving them loan, right? I mean, if I am teaching a class within US, I should have used African American instead of even using a black as a name, right? So this was essentially the issues. So in terms of how this whole thing worked, so this had this this approach essentially brought down the training time required for models, because this representation carried a lot of semantic information in there. And so the models could actually leverage the semantic information and learn things much, much faster. So it needed less examples. Because of that, it required less iteration, and we were able to train a lot more accurate model in a shorter period of time. And this was a big breakthrough in 2014. Okay, so I have some examples, some demos. I'll actually, next week, I'll actually have the demo. And I also did, for example, so now I'll give you a preview into what we will discuss next week, right? So this same concept can be attributed to all the varnas in Sanskrit based on Paniniya Shiksha. Except instead of training them statistically, we can actually use them we can essentially assign values based on the the statistical analysis that has been already done by Maharishi Panini in terms of sthana, prayatna, viveka, right? The whole idea behind that. And now, if you actually look at it, now you can actually start solving sandhi doing mathematics like this. You would see, if you want to do Purvasavarna Sandhi, you will actually see that you would need to do Jashatvam in between before you can actually apply them. Even though when we are taught, we don't have to consider that. You can see it has more Jashatvam towards, so you will actually show that you have to do the transformation in 2 steps instead of just 1 step, which is actually the natural way of doing it. Even though we are taught to do it in 1 shot, right? Plus ka is nga. So, right, it is aham plus karaha, ahankaraha, right? Like things like that. So I actually did some experiments, and I actually have a demo that can actually illustrate. So using a tool where we can see that and all that stuff. So I actually have some for the words themselves, and where we have so done some taken a dictionary and essentially computed embeddings, and we can actually analyze the dictionary in just, for example, we can take, for example, Vachaspatyam or Monier Williams dictionary, and we can look at the association of our own Sanskritam words in this. So one thing I see is the OpenAI model is actually not that coherent for Sanskritam compared to English, compared to the Gemini model from Google, right, which has a more inherent support for Sanskritam. I can actually show some of these examples, and we can play. Next week, we will just discuss like live examples of these, play around with some of them, and I'll probably also give you access to this to be able to, for you guys to be able to do it. I'll actually give you a setup information and how you can set it up and play around with it. Okay. Good. So I'm going to stop the recording. So actually, let me do the shloka and then stop. Purnamadah Purnamidam Purnat Purnamudachyate Purnasya Purnamadhaya Purnamevavashishyate Om Shanti Shanti Shanti.
So before you stop the recording, what exactly is the embedding here?
So embedding is essentially this representation. So this number you are seeing, right? Age,
Okay.
gender, and royalty as 3 dimensions is essentially the embedding representation.
Okay. Fine.
And we will essentially go through this in detail. So now you kind of understand how it allows you to do that mathematics, right? You can actually index them, get the vectors, you do the math and convert these vectors back to the world.
Okay.
And that is called, you should be translating embeddings in its literal sense. It's actually not a noun, and rather think of embeddings as curated representations. Right? So we are not taking and embedding something in somewhere. So what we are trying to say is we are digging out the embedded semantic values out. Okay. Let me stop the recording.